So thanks, Robin, for coming today. Robin Lester is a cloud solution architect at Microsoft, working in one commercial partner to help partners bring data and AI solutions to market. He has over 20 years in the industry, specializing in databases, data warehouses, and machine learning technologies. Robin's going to be talking to us today about data architectural patterns and trends in cloud computing. So as I say, everybody, just keep your mics muted, and thank you so much, Robin, and hand over to you now.
Okay. So if anyone does have any questions as we go through, just let me know. We'll leave some time at the end for questions as well. Just to caveat this, we're talking about data architectural patterns and trends. This will be somewhat from a data perspective due to my background, but we'll try and talk about other areas as well, but most of the examples we'll give will be around data. So we'll start off. I'll just do a brief kind of intro to Azure for anyone that's not familiar. Why you would want to start using Azure. So really, we're talking about our software has suddenly become part of every organization. So everything from education to healthcare now have software developers in it and are developing software products. The days have gone where you don't have an IT department in a company. Every company has an IT department. Every company has development. Development gives you competitive advantage. So companies that aren't doing development, I guess, are the companies that aren't doing too well. So let's talk about Azure. So what is Azure? So Azure comprises of several components. It comprises of cloud components. It comprises of edge devices, and within it we have compute, we have networking, storage, security, identity, etc. And within those actual services that we have a massive range of services, and this slide really is just talking about a very, very small subset that we have, but generally we kind of bucket them up into these areas of web, databases, mobile, analytics, AI, machine learning, etc. Used to be the case that we were anti-Linux. So probably remember this quote from Steve Ballmer way back in the day: "Linux is a cancer that attacks itself and an intellectual sense to everything it touches." This is not the modern Microsoft. And Steve himself has said that now it's done a U-turn in the importance of things like Linux in the modern infrastructure. So Linux is technology that is growing very, very fast on Azure. You see from here we have over 60% of all VMs are now Linux. And we also, as a company, we are the biggest, now become the biggest contributor to open source. So this is showing our contributions in GitHub. So here we are in a complete U-turn to where we were 10, 15 years ago. We very much embrace open source and are the leading contributor to it. Okay, so and as such, everything we do in Azure is designed around making it easy for developers to be able to use those tools, and so be able to use Azure using the tools that they're familiar with. That might be open source, it might be proprietary stuff. As you can see from this slide, things like Puppet, Chef. We have big data technologies such as Hortonworks in there. We have infrastructure, things like Red Hat, Docker, Kubernetes. All these different technologies are all key and important. So how Microsoft runs is it kind of looks at industry trends and looks at what's going to give its customers and partners the best technology and the best value, and then incorporate that technology into it. So a good example is in the big data space, where we see since 2012 really the kind of big data revolution. We've seen an evolution of those technologies to the point now that Spark has become one of the key technologies. So we now have integrated with Databricks. We have Azure Databricks in place, which runs on the Spark engine, and we now have Azure Synapse, which is on-demand Spark clusters as well. So just an example there. So another view of all the different types of things you can use with Azure. So like I say, you don't have to use Visual Studio, you can use Eclipse. If you're running on a Mac, you can use Visual Studio Code. We try and make it accessible as possible to developers. We have 60 plus regions around the world, and we have one of the largest networks in the world, with cables overseas, underseas, etc. In terms of trust, I think in a lot of surveys, Microsoft comes up as the most trusted company in the world, certainly in the technology space. And because we live and die on trust, if people weren't secure, didn't feel secure and safe in putting the data into Azure, we wouldn't have a business model there. So we make sure that we are the safest and securest place you can possibly put your data. We pride ourselves on being more secure than if you were putting it in your own data center, and we have many different security mechanisms in place within Azure Data Center. I can't really talk about many of them, but there are a lot of security threats in place, and here we have many compliance offerings as well, just to ensure that you trust us and your data is safe. These are our different data centers at the moment. We're always adding new data centers all the time to population areas that make sense. We even have offshore data centers where we can, recently we've been trialing putting a data center into the ocean. A data center probably about the size of a small house, putting it offshore, using the ocean to cool it, because one of our biggest costs is cooling in our data centers, and using that as a mechanism to supply low latency Azure data centers to places where we haven't been able to actually create a large physical data center. So we've just recently pulled that up, and we're just going through the data from that. We've recently added satellite connectivity as well to our data centers, so dedicated satellite links. And in terms of Azure, 95% of all Fortune 500 companies use Azure. Okay, so that's the kind of marketing slides out of the way with. Let's now talk about how you might go around architecting for the cloud. So what we'll try and do is we'll try and kind of give you a honest view about how things you need to consider when you're moving an on-premise system up into the public cloud. Because there's some things, there's some gotchas, some things are different, and we'll talk about how you go around creating a good architecture. So I like to call this the 6 S's of an architecture. So we talk about simplicity, so making sure that any architecture you're developing has fewest components as possible. If you've got something in there where you could get rid of it, get rid of it. Any component you add into an architecture is going to add time down the line in terms of support, in terms of documenting it and knowing exactly what it does, all this kind of stuff. So keep things as simple as possible. Excuse me. I would just caveat that simplicity is good, but also you need to take into account there are quite a few products out there that are jack of all trade kind of products that can do everything. So for example, SQL Server I always use is a great example. SQL Server is really good at doing lots and lots of different things. It's not necessarily the best at doing some of those things. I mean, obviously it's the best at doing relation databases, but if you want to do something such as use it as a object database, maybe it's not going to be the best thing at doing that. If you wanted to do, you can do graph databases in it, but it's not a dedicated graph database. So maybe you'd be best off using something like a Gremlin or something like that. So in terms of simplicity, keep things simple, but also bear in mind that you want to use the best tools for the job. Scalability, making sure that your architecture is able to grow. Again, jumping back to SQL Server, SQL Server itself is not partition tolerant offering, so it doesn't scale out into multiple nodes. It can scale up, but you can scale it out, but it's coding to scale out, as opposed to solutions such as Spark, where it will scale out. So it's partition tolerant, it will scale out, add more and more nodes to it, and you don't really have to do any coding. So always think about scalability. So horizontal and vertical scalability. So you want to be able to, for your problem, be able to get the right amount of compute power to that problem that you that you need to get. So make sure you choose the toolings that's going to let you do that. Not that I'm saying don't choose SQL Server. SQL Server is absolutely relevant, but there is a ceiling on it, which might be a ceiling you may never meet. So it might be a good choice, might not be a good choice. So security and accessibility. Can people connect to the right components? Is the sensitive data secured? So in Azure, we use Azure Active Directory for most of our services to make sure that your data is secure, to make sure only the right people have that kind of level of access to it. Supportability, can the team support the architecture that you're developing easily? This is usually quite a big one. We tend to find that that with the wealth of different services out there that you could choose to construct a solution, sometimes it just comes down to in-house skills. For example, we've just been talking about Spark. Do your in-house developers, are they able to code in PySpark or Scala, or are they SQL developers? If you're coming from maybe a SQL background, does it make sense going off and creating Spark clusters when you're going to have to reskill all your people in terms of your developers, going to have to reskill all your support teams into those new technologies? So supportability can be a big consideration, and naturally should be a consideration in terms of just thinking about how expensive that architecture is to put in place. So supple, so can new components be added easily? Are you in an ecosystem that lets things talk to each other? So in Azure, we pride ourselves on ability for all of those different components to be able to talk to each other, which obviously can add complexity itself, but yeah, so make sure that components can talk to each other. And also what we've been trying to do is to try and give you what we call a single pane of glass for different problems. So things like data ingestion, data manipulation, and presentation, all of those kind of things you might do in an ETL process. We now have technologies such as Synapse, where we put lots of different technologies in there and wrap them all up, so you have a single kind of pane of glass. If we have time, we'll demo that later. And then last one, stamina. Will the architecture be visible in the midterm future? Are you creating an architect? Are you using toolings, be it open source or be it from an organization? Will those toolings be around within 5 years, or will you have? I mean, 5 years is a very long time in IT, but will those technologies be around? Are you developing something that basically has got a shelf life to it that will now become obsolete, and you have to redevelop it completely using something else? And also updates as well to the architecture. Will updates that happen potentially be negatively affect? So again, open source is a great example. Open source, whenever people are developing open source, they develop it for cool new features, that kind of stuff. They don't always think about the enterprise needs. They don't always think about is the next version going to break things from 2 or 3 versions back? So that's a consideration, especially if maybe a big data problems are pretty typical here. If you're using services under Hadoop, there's a good chance that a next version may not honor what you've developed in a previous version. I've certainly seen that in earlier versions of Spark. So we had choice in Azure. So we have, what we try and do in Azure is we have IaaS services, so infrastructure as a service, and we have PaaS services, platform as a service. Platform as a service takes away all the pain of developing, all the pain of supporting, in terms of you're just consuming a service. You don't have to do operating system updates. You don't have to understand operating configuration. For example, a good example would be something such as, again, SQL Server. You can have SQL Server on a VM, in which case you have to update it. You have to monitor the operating system. You have to do updates to the operating system. You have to updates to the SQL Server, or you can go for something like Azure SQL Database. We don't have to worry about any of that. You don't have to worry about HA/DR. We do all that behind the scenes for you. You can add additional HA and DR to it, but you don't have to be involved in any of that. So PaaS solutions are really the kind of trend of where people are going nowadays, because doing things such as database backups, doing things such as monitoring and always on availability group, doing that kind of stuff is costly, and it doesn't add anything to your business. It's just time you're spending for no reason nowadays. So when you have PaaS solutions. Now, in terms of choice with our PaaS solutions, there is a lesser choice because there are less PaaS solutions than there are if you went for for example, here in this slide, we have the big data landscape. So all of these, you probably can't read them all, but these are all big data offerings that are out there and available. And as you can see, there is a massive amount. Some of these will become irrelevant in a year or two. Some of them will go on to be around for a while. But understanding how what's going to happen, the industry trends in there, not necessarily choice isn't necessarily a good thing. So when we using Azure, we offer you the kind of best of breed here. So if you're this example looking at big data, you might go for HD Insight, where we offer all the kind of key technologies we know that are going to be around for a while. We offer Databricks, which has Spark in it. We also offer Azure Synapse, which has Spark in it and SQL in it. So when you go for PaaS solutions, you know that you're going to get something that has longevity, and you know that you're going to get something that's is going to be supported. If you pick one of these, maybe it'll be great, performant and good for a year. So it's a question. Okay, so it'd be good for a year, but then it might be that those people that were developing that open source go off and start doing something else, and then you have to either ditch it or start developing it yourself. So yeah, there's choice, always a good thing. So just to give you an idea of how different it's still keeping on with the kind of theme of choice. It's your traditional Lambda architecture, where you have your hot data and your batch data. And I just what I've done here is I've just put in a few different kind of components just to show all the different ways that you have of moving data and the different kind of toolings that you might consider doing. So if you're new to the Azure ecosystem, yeah, we do have a lot of stuff in there. Some of it can look like it's similar to other stuff, but everything has its own purpose, and everything has its own point to it. So for example, we have Service Bus, which is a streaming technology. We have Event Hub, again, streaming technology, and IoT Hub, which is the streaming technology. IoT Hub adds a layer of management around devices. So if you have IoT devices, Service Bus gives you more transactional streaming data. So it's a queue that when you write onto it, that it doesn't get deleted till someone reads off it. Event Hub is more large scale streaming data, so you can write to it and many people can read off to it at different speeds, at different elements. Then we have things like Kafka in there as well, if you wanted to go down the open source route. So we have a lot of choice in here, and we also and the choice that we give you is not only our own products, it's you know, products such as Spark, such as open source products as well. So with cloud, you have new ways of buying. New ways of buying gives you less cost and more performance. With cloud, if you're on an on-premise architecture for on-premise, you would probably have to architect your performance for the next 3 years at least. So by servers, etc., that were going to still be able to deal with the amount of data you had that was going through, assuming that you knew how much data you're going to have going through in 3 years, because lots of stuff can happen in 3 years. So if you're architecting for the cloud, it's always best to choose architectures that allow you to turn off components when they're not needed, to be able to scale up, be able to deal with unpredictable bursting, or predictable bursting. So things such as if you were in retail, you would want to be able to have servers that were able to spin up around Black Friday seamlessly, so no one would necessarily notice that there was a lot more traffic going through your site. Be able to, for example, if you've got a reporting solution that you're giving to your customers, and those customers only actually look at those reporting solution 8 hours a day, 5 days a week, the ability to turn that reporting solution off so it doesn't cost you any money saves you a massive expense. So 40 hours, just running on 40 hours, because it saves you, it's only 75% of the time, so you're only paying 25% of the cost if you go down a route of choosing services that you have the ability to turn off and on. We've talked about PaaS and IaaS already. It's just a illustration of that. And in terms of choice, so just using SQL as an example, so coming from a data background, of the new ways that we have of being able to offer different levels of performance to you. So you can still just spin up a standard SQL server. You can put SQL servers in a shared pool. So that shared pool, we call Elastic Pool. That pool basically is sharing CPU and memory. You can have your SQL servers in what we call serverless, in which case it will auto scale. So it will scale down to use half a core when it's not being used, or will scale up instantly to use several cores, depending how you set the queue. And it can even turn itself off and go to sleep when no one's using it. So again, great for those patterns where you have on/off in there. Then we have our open source databases that we offer as well, MariaDB, MySQL, Postgres, etc. Okay, so kind of some kind of considerations, gotchas that we've seen out when people have been moving to a public cloud. Often we see people that don't understand, so don't reinvent the wheel, don't understand the amount of stuff that is in there. I've certainly sort of spoken to people that have moved to Azure, looked at IoT Hub and go, I wish you would have known about this a couple of years ago, because we've written our own software that does exactly the same as this, maybe not as complete, and they would have saved themselves years worth of development in just actually looking out to see what is there. Another good example of cognitive services. Cognitive services are basically AI services that use deep neural networks to do things such as voice to text, voice to speech, image recognition, OCR, etc. And they can save you, they're just a web service you call, so they can save you a massive amount of time. If you had a problem where you had to identify I don't know, something in an image, do object detection, you're going to have to, if you weren't using something like our cognitive services, you'd have to go off, write deep neural network, work at which kind of platform you're going to use, algorithms you're going to use, what type of deep neural network, train it, we get lots and lots of images to go off and train it how to understand the world. And it's going to take you a long time. Whereas with things like cognitive services, you can just use the computer vision to understand what things are, people's faces, that kind of stuff. Or if you have a more specific problem, you can use custom vision, where we use what's called transference learning. So we use a deep neural network that we've already trained, and that deep neural network can be used to just train things in a domain. So for example, if you just wanted to identify cars, you can go and tell it that, you know, these are what cars look like, and it can go off and be able to see cars, detect cars. Sorry. Okay, so another kind of consideration of moving to the cloud, storage is cheap, much cheaper than it would on premise. And in any kind of data warehousing style scenario, because the storage is so cheap, duplication is usually not a problem. So with things such as data warehousing, you might want to store the data in different formats, different ways, and you have the ability to go back and understand what the data looked like when it landed in your system. So the kind of concept, we're going to talk about data lakes in a bit more depth, but the kind of concept behind data lake is data lake is a write once, read many. It's a mutable data format, so the data never changes once it lands. You just create a duplication of that data, do some stuff to it, maybe change the actual format of it, and then stick it in another zone. So because data storage is so cheap, it's not a problem to do that. The only caveat I would put behind that is that make sure you have your data make sure you're controlling your data. You have a data lake, not a data swamp. So you have your data in a way that you know where it's come from, you know what stage it's at, you know if anything has been done to it and what's been done to it. so you can always kind of go back and understand what your data is and where it is. This is a gotcha that is top of mind at the moment. So we have capacity, yes. If one of our data centers were to be blown up, what would happen in those kind of scenarios? Now, our data centers do have a lot of capacity in them. We don't run data centers with over 50% capacity. It's not a business model that makes any sense to do that. If you have if you have two data centers, now what a lot of people do is they will have their components running in one data center. They'll then have warm standbys or hot standbys in the secondary data center. So for example, I'll use SQL again. So I might have SQL Server running in one data center, and I might be doing an asynchronous data copy and have SQL Server running in another. So if a disaster happens, the data center might go down, but I know that my service is all there and nice and secure. Whereas what some people do is they won't consider the impact of a data center being blown up. If you put all your data, everything into one data center, yes, it's all backed up and it's all you can have geo redundancy in the storage, etc. So that data is in another data center, but the services that you're going to want to spin up may not necessarily. There may not be capacity in the second data center if everyone from the first data center wants to move across. So into the scenario with that data center blows up, and we can facilitate. We have lots of space in our data center, so we can facilitate some people moving over, but not everyone will be able to get that space. And this is it, and this is the same for any public cloud vendor. If you don't have something already in that data center and everybody else is moving across to it, you will be throttled back. There will be that consideration. So we always advise customers and partners to have a full disaster recovery system where what they have in the secondary data center. So what they have in the first data center is in a warm state on the secondary data center. So no one's going to turn off your services in the secondary data center. It's only if you're coming new to a data center with all the other people that haven't actually really thought about disaster recovery in that respect. Other kind of gotchas when moving to the cloud. So you are in a network. It's a cloud network. It's not the same as your on-premise network. So an on-premise network is very tightly controlled. You know exactly what's happening in that. It's less controlled in the cloud because it's all there's a certain amount of shared infrastructure up there. So sometimes you can have a network can have blips of latency that go between them. Sometimes you can have services that are in a state of being spun up. So if you have a service that goes to sleep and comes back up, it's like SQL Serverless, you might have to wait for things to spin up before you can talk to them. I mean, service takes about 60 seconds to spin up. That still can be a bit of a long time to wait if you're running an application. And that's from sleep. So that's like an event that would happen once a day. Or you might have resized one of your services. So sometimes when you resize a service, there will be a bit of a blip. So things such as, so let's say you were talking to a database and then you decided to resize that database, people would still be able to use that database as it's resizing at the point that it was now the right size. It would move traffic across from the old one to the new one. Conceptually here you wouldn't actually see this, but conceptually there'll be an old and new one. That will kill any transactions and then accept new transactions on the new one. So general design patterns, anything in the cloud, regardless of whatever cloud it is, you should always have retry logic in your application. So your application should always, if it gets a timeout, if it gets a connection, try again, and then you should be good. So in writing your applications, a lot of applications, if they've been built on premise, don't necessarily have that retry logic in them. They just try, oh no, I've got an error, put that error up to the screen, do retry logic in a cloud environment. Okay, so we have different regions in our data centers. So this is public documented. which data centers we have with different regions. So UK South is 3 regions, whereas some data centers are only 1 region. So when I talk about region, I'm talking about a physical different building that the data center is split across. So in UK South, in London, that there are 3 data centers, and the data is and the services are split across them. Now, if you have a chatty app, for a start, you need to be careful. You need that chatty app to be close to the data that you're deploying to, because coming from an on-premise network, you're going to have very, very low latency. Moving to a cloud network, if you have put your services in different data centers or different regions, then that's going to add latency to it. So services talking across regions, talking across zones, talking across data centers, or talking across zones in a region. You need to make sure if they're chatty, that then you're adding down, adding additional time to your transactions, additional time to the kind of things you're doing. So just always consider where your different services are being deployed and make sure they're being deployed close or next to each other. So in terms of network, you can talk from on-premise to cloud, and hybrid's quite popular kind of pattern that we're seeing, and different ways of doing that. So you have you can virtual private networks. We have express routes, which is a technology where your data never leaves a private network. So your data moves up to your ISP, and then that data goes from that ISP across into Azure. So kind of like an MPLS network. We also have gateways. At the end of the day, it's always best to have, like I said before, always best to have your different services that talk to each other as close as possible. Now you can have different ones on premise. It's a cloud, and that's something that maybe you have to do, but at the end of it, it's always best to have them close as possible. Considerations still, DevOps and ML ops, writing your code as infrastructure as code, so you can spin up lots of different components as and when, and it's all controlled in code, and you've all got it nice installed in Git. That's pretty key to being able to deploy to the cloud. Cloud's all about scale, all about being able to use that scale, and if you can deploy to that scale as code, then brilliant. I mean, obviously you can't do it on premise because you can't write code that makes tin, but yeah, you can do it in the cloud, and that's absolutely something you should be using. You should also think about polyglot architectures, so making sure you're using the right kind of tools, the right job. For example, if you wanted to chop down a tree, you would probably use the chainsaw, but if you wanted to open a bottle of wine, maybe you'd use the penknife. And again, going back to something like SQL Server is a bit of a penknife. It's brilliant at doing relational database stuff, but it does do lots and lots of other stuff around it. Maybe a different tool might be best for those kind of things. Like I said, an example before was a graph database. So cloud trends, just pausing to see any good questions before we move on. Okay, good. Right, okay, so customer environments, they're getting more and more complex. We have more applications, we have more infrastructure. We also see a trend of multi-cloud. So especially around Fortune 500 companies, generally the boards aren't too happy about having all the eggs in one basket. So we see more and more often components being shared across Azure, AWS, Google Cloud, to name a few. So this can also change the kind of architectures that you choose. So if you want something that can move easily between AWS and Azure, then you're not going to be able to necessarily always use things such as the PaaS services. You might need to use virtual machines, which virtual machines are more expensive to use than the PaaS services. They're expensive in terms of, well, expensive in terms of cost and expensive in terms of time in supporting them. So those are considerations in that respect. It's always best to use the PaaS services rather than IaaS, but it does depend on what you have to do in terms of making that a multi-cloud environment. So there's obviously the two pros and cons in there of sticking with one vendor or going across multiple vendors. Obviously, we'd much rather you just start with us, but obviously there is, you know, that we do understand the need sometimes to have these kind of multi-cloud hybrids. And because, sorry, I'm just going back on that, and because of that, all of our services that we use are able to connect across the different clouds. So, for example, one of our key services for data movement, Data Factory, that will have components in to talk to AWS components, talk to Redshift, etc., talk to Google Cloud. Okay, so we have hybrid architectures, which we touched on before, where you have some cloud and some on premise. We have things like Azure IoT, so you can have edge devices, and on those edge devices you can deploy components. We even have things like our cognitive services as ability to put them into Docker images and put them on premise. We have things like SQL you can have on premise, Stream Insights, which is a stream transformation service you can have on premise as part of these devices. We have Azure Arc, so you can deploy effectively a copy of Azure on VMs, so you can choose any data center. So when we were talking before about multi-cloud, you could go to AWS, spin up some servers, and deploy Azure onto it, or any other cloud. And we have Azure Stack, so you can deploy on premise. So you basically buy a stack of servers, and then you can put that in on premise, and you can run Azure on it. This is usually kind of more for military, where it needs to be absolutely sure that that data doesn't ever physically leave the boundaries of a room. But yeah, it depends on your industry. Most industries, with kind of level of trust we have, are okay sticking everything in Azure. But like I say, some very specialist industries might want to consider Stack. Okay, so the trends we see, so move to PaaS, because PaaS is going to save you time and money, make your developers happier. They don't have to do the mind-numbing kind of jobs that you might have to do if you had a IaaS solution in terms of doing updates, all that kind of stuff. We see it's a trend towards serverless technology, so abstracting services, having them in containers. So we see that Kubernetes obviously is very big trend as well. So we have Azure Kubernetes, as well as different container services. So just giving you more options. So Kubernetes is great if you want to cluster up running all the time. But we have ACI, Azure Container Instances. If you want to just pay as you go kind of structure, where you just want to spin something up, run something for a bit, then rip it down. Again, moving on to this one, pay-as-you-go and scalable are pretty much where organizations want to be. They don't want to have that capital expenditure. They want to be able to be paying for a service that is making them money, so they can manage their finances easier. So they know that as soon as the service stops making them money, they can rip it down, and they're not left with a server room full of hardware that is now is either useless or has to be put into and reconfigured for something else. So things such as so we see things now. I talked about Azure SQL Database Service, which lets it can go to sleep and it will scale up and down depending how you use it. We have things like Synapse on Demand, which is a SQL cluster, kind of data warehouse cluster that you run a query, and you're just paying for the fact that the time. In fact, this one's built on data, so I think it's $5 for every terabyte of data that gets processed through it. So very cost-effective way of being able to run a large amount of it used a large amount of compute power. Because most of the time, if you're doing kind of heavy lifting with data warehouses, you're not going to be using that data warehouse 24/7. So I want to talk about a few kind of concepts around here about the difference between data lake and data mesh. So data lakes, you're probably familiar with. I'll just cover some of these off though. So data lake is really, said before, it's a lake of data. So you move data in, you normally have a raw area for your raw data coming in, a staging area for data that you've changed. Some people might call this bronze, silver, gold, platinum. Just that as you move the data through your pipeline, you're making the data quality on it, and you're taking the data and you're turning it into formats that are more performance. So you might be moving it into a Parquet data format, so it can be read easily. Data lakes kind of come from the kind of big data concepts of the 3 V's: volume, variety, and velocity, which actually you can split up into, I think it's 12 different V's, which are worth considering if you're developing an architecture, worth considering how all of these operate. So think about the volume, the amount of data, the speed of the data, the variety of structure, the data structured semi-structure, variability in it, the veracity, so confidence or trust in that data. Is it good data? The validity, how accurate the data is for its intended use. Vulnerability, how sensitive the data is. Volatility, how long it'll take to become irrelevant. Visualization, how to visualize the data, and the value that you get from that data. So is it actually worth storing? Is it going to give you value now or further down the line? So all of these are kind of considerations. And so we have a service called Azure Data Lake Gen 2, which is effectively it's blob storage with a hierarchical file format on it to be able to deal with a massive amount of data and bring that data back in a very fast way. It sits with Active Directory on top of it, so it deals with the kind of vulnerability areas of this. You deal with any kind of data. In fact, it covers pretty much all of these V's. So normally, if customers that think of data lakes, they're coming in with the problem they have data silos. They're coming along needing to put analytics on top of all those different bits of data. They have problems in terms of performance at scale, i.e., can they scale up the kind of things? Is the data getting bigger and bigger? Do they have the ability to handle all that data, or does the data start getting put on multiple disks all over the place? And the security around that data. So when people start to think about these kind of pain points, start to think about how you would go and make that move to cloud and what the advantage that cloud's going to give you. So in this example, we maybe have someone with a Hadoop cluster on premise, lots of servers that they have to maintain. And if you move up into cloud, I just want to get the concepts across that we have the data lake. The data lake can present itself as HDFS, can present itself as different APIs. We have Azure Active Directory in it. It's secure data lake and can handle massive amounts of data. And there's in the cloud, there's a separation between compute and storage. So we have some compute here that you might want to use. We have storage, so you can expand your storage, probably not shrink it, but you can shrink it if you want to. And then you have all the different compute layers, compute services that can shrink if they want to. You can turn them off, you can turn them back on. And this relationship here is many to many. So you can have multiple different compute talking to the same data lake, or multiple data lakes with one compute talking to them all. So that kind of flexibility is really one of the key elements of moving to cloud. The fact that you can turn things off, they're going to save you money because you're not running them. Compute's usually the most expensive thing. So you can just load data into storage and then decide what you want to do with it further down the line. I'll skip over this one. So concepts of a data lake. Control who and how the data is loaded into the lake, load data in its raw form, and then you can move it into better forms. Always copy data, never delete or overwrite, so immutable data. Make sure it's usable by multiple technologies and create a hierarchy. So this is kind of pretty key. Here we have a concept for a data swamp where we have all these different elements of data all over the place. Here we have a nice data lake where we have our elements split out. So we might have a Twitter stream, product A and product B coming in from the Twitter stream, the date, year, month, day. So we know exactly where it came from, what type of thing it's about, the year, the day, the year, the month, the day, and so we can go back to that data and then you obviously have tooling over the top of it that will be able to scan across multiple areas of your data lake. Different types of files. So consider how much in different file types in storing the data in your data lake. Pretty much Parquet has kind of won the battle of the best type of data to store it in. We did have ORC for a while. I mean, an RC file as well, but Parquet seems to be the standard. That's due to the popularity of Spark, and Spark favors Parquet. So now Parquet seems to be the overall technology data storage type that a lot of different servers can read it. Big data services, obviously Excel, as far as I know, can't read a Parquet, but things such as data warehouses, etc., can. I'll skip over that one. Okay, so let's talk briefly about data mesh as well. So this is architectural kind of paradigm through ThoughtWorks. So I'll read this out. Data mesh is an architectural and organizational paradigm that challenges the age-old assumption that we must centralize big data to use it. We talked about data lakes and putting everything into one basket. Data mesh is kind of challenge that idea a bit. I still can use data lakes, but it's a bit more of a challenge to the fact that it's not just about the data, it's the usefulness of the data. So data mesh, it's a domain-driven architecture. So it's all about the domain that the data is in. So it's more about is this HR data rather than here's some data, stick it into a data lake. So it's more about the domain it's in. It's more about taking ownership, people taking ownership for that domain of data rather than people taking ownership for this data lake that's got some data in that who knows what's data's in there. So some of the other concepts behind it have self-service as a self-service in there. Product thinking, like I said before, treating the data as if it's a product. Ecosystem governance and a decentralized architecture. So all the architecture, rather than putting things into one big data lake, the architecture is about putting things into architectures that make sense for that data. So it might be that data is image data, in which case it's not going to make sense sticking it into a SQL database, but then you might have a data domain that is just relational data, in case it makes sense, not maybe necessarily not stick it into a physical data lake, maybe it's stick it into a SQL server, which effectively then becomes your data lake. A data lake doesn't have to just be a blob storage structure. A data lake can be something that holds data such as a SQL server, like a NoSQL database, as long as you're still treating that data as immutable when it lands, and then you're doing some processing on it, so you always can go back to the original layer of data. Okay, so so I just talked about all that already. So you always think about your data as a product, and so like I said before, it might be you putting it in SQL, might put in something like a Cosmos DB. Your data must be self-describing, so it must be able to be used for self-service. So discoverable, self-describing, data must be shareable. People has to be trustworthy data, and kind of key concept is that you have a data product owner role. So you don't have just someone with the role of I am going to look after the data lake. You have someone with the role of I'm going to look after the HR data. I am going to look after customer such and such data. So you end up with something like this. Now, this is actually, and think about it, this isn't best visualization because we have the same architecture over and over again. It might be that you have different architectures in here for your different things, which make more sense for those different data domains. But yes, you do end up with multiple architectures. So that's why infrastructure as code starts to become really important, because you can just spin up a new architecture just for that particular data type, whereas previously it starts, it would be a pain if you had to do everything from scratch. Right, let's create this whole infrastructure. You end up with infrastructure code that can give you a base architecture that you then just customize to the data domain that you want to deal with. So some of the kind of Azure toolings that we have that help in this respect are for self-service discovery. We have Azure Data Catalog, we have Power BI. We have lots of different kind of polyglot databases like Synapse, Cosmos DB, Azure SQL Database. We have government systems in place such as AAD and all the other security systems we have in place. And we have, as I said, infrastructure as a code with things like we have a CLI, command line interface, we have PowerShell, products like Terraform that will help you do that as well. So taking on those kind of concepts, let's, I realize we've gone over slightly over time. By time, I'll just show you this. This is Azure Synapse. So this is where we've kind of taken this concept of being able to spin up an architecture with all the kind of key components in it that will give you the different ways of holding your data, different ways of running compute on your data, all the way from ingestion up to presentation. So we have inside it, in fact, let's do it this way. We have inside it SQL pools. So we have on-demand SQL pools. We have massive parallel data warehouse there as well that at the moment mine's paused, so I can spin that up on demand. You only pay for how much data you push through it. We have Spark pools in here as well that I can spin up a Spark pool. I can choose how many nodes I want that Spark pool to be. We have in here as well, we have things such as a data pipeline, so we can go in and we can push data through using a graphical interface. We have the ability to, so I'm just using a Spark on demand when I run a query. From here, that's because I'm demoing it, it's going to take more than a few seconds. Okay, so when I run a query, I can see that the visualization of that data as well. So it's good for a big data. You've got a lot of data in there. That's not really telling me much in how much see it in traditional tabular form, but I can now see. So this is Twitter feeds coming in and how many tweets we get in. So you can see that the tweets are coming in a pattern. We have this is integrated into a data lake. So I have my data lake here, where I have my all different file formats. So here we go. Here's a data lake component. So this was some stuff from 2000 January. So I have files here. I can quickly look at that data there. So as you see, right click, and at no point I'm being asked for security because this is all integrated into Azure Active Directory. So it all integrates and it all works, and people that don't have access will be refused access for different things. Again, let's visualize that. And all the way up to being able to write Jupyter notebooks in here as well. So it's doing data science in here. So I click on one of them. I'll get my Jupyter notebook up here. That might be a better example to but and even to integration into something like Power BI. So this is Power BI, and this is just using the SQL on demand pool. So let's do something. Well, there's that Twitter feed that we just looked at, and we can put some machine learning on that here. So this is just a couple of clicks to do a forecast of what's happening with that data. We can look at, here's some police crime data. So this is about, I think it's about 500,000 rows of data in here that we can just go in and look around. And this is almost costing me no money because I'm just using the SQL on demand. So this will cost me $5 for every 1 terabyte worth of data I'm pushing through, and a million rows is nowhere near a terabyte worth of data. Okay, so I've given you a very quick run through of that. So I realize we're just about out of time. So any questions on anything that we've covered so far?
Thanks, Robin. That was really
I
impressive.
have just a quick question
Mm-hmm.
regarding something you said at the beginning. So you said a SQL server is not really good at synchronous replication. So my question is, are backups like the only failover strategy?
Okay, so SQL Server, yes. So so SQL Server can do synchronous replication. It's just once you get to the point of moving between 2 zones. So if you're going from Amsterdam to Dublin, you want that replication to be asynchronous. So SQL Server, so if you spin it up in a PaaS services, it will be in a synchronous always on availability group. So there'll be a primary and multiple secondaries. Then if you want to go to a different geographic region, it'll be an asynchronous movement. So the data will be offset by a few seconds between those 2 different ones. So sorry, does that answer your question? Or
yeah, so there is actually something in terms of that. Okay,
yeah,
thank you.
You basically had hi Robin, sorry. You basically had very little mention of compute. Is that just because like you're just pushing people away from IaaS?
Okay, so so we didn't talk about compute much. So some of the reason we didn't talk about compute much is because my domain's data, so I'm talking more about data. In terms of compute, yes, we do have lots of compute PaaS services in place. I just didn't mention them too much because, like I say, my domain is in data. We want PaaS is best for us and you because it gives you all the benefits of of that service without the need to do all the painful stuff in there. So yes, we would rather people used the PaaS services, and that those PaaS services will cost cheaper, and much cheaper than using IaaS services. So yeah, we would rather people use PaaS than IaaS as an organization. But that's not to say that IaaS is still very relevant if you have something that isn't offered in PaaS. But we do offer lots of compute PaaS structures. We just didn't talk about them.
Yeah, sorry, just to add to that. Sorry, Edward, was that in the context of compute for the data workload specifically, as in the
No, not really. No.
Oh, okay. So yeah, I mean, we can cover more infrastructure type stuff on other things, but we absolutely have architecture available that will cover from small workloads through to big scale out things using GPUs on the back end, low latency, InfiniBand if you've got those kind of requirements.
Yeah, I mean, my previous experience is more with like big compute loads, so like big scale sets on Service Fabric and things like this. So I was just kind of interested to see if there was more cheaper versions, because I don't know much about compute on PaaS really. So yeah.
Okay. Yeah, I mean, with PaaS, it's sorry, Robin.
Okay.
But yeah, with that, you're more specifying by the workload what performance you want from it. So I think even with a lot of the data services, when you're spinning them up, you're kind of saying what you want to achieve in terms of performance, and then it provisions the workload underneath for you according to that. It's just, you don't really have to concern yourself with what's under the skin. You just say, this is the amount of, Robin, please, what's the correct, is it DTUs or?
Well, the DTUs is a model. We kind of moved more to vCores now, so it makes more sense with what people are used to on premise. But yeah, you choose. So if it's a SQL database, you choose how many virtual cores you want. If it's but we do have some still. Different services have different concept of SKUs. So what was called Azure SQL Data Warehouse, now called Azure Synapse Analytics, that has the concept of data warehouse units. So you choose how much power. It's just basically it's a power slider that you choose for regardless.
Yeah, cool. Thank you.
Any other questions? Okay, so I think that's all the questions, Robin. If people have further questions, how can they reach you?
They can email me, so robin.lester@microsoft.com.
Perfect. That's brilliant. Well, thank you so much for your time. Thanks, Robin, and thanks also to Matt. We really appreciate it. And yeah, we'll be putting the recording on the YouTube channel.
Great.
So thanks very much.
Thank you.
Thank you.
Thanks,
Cheers.
Cheers. Thanks.
Cheers.